Right, so this should be a really nice quick video today. We're going to look at weight and mass, we're going to look at the difference between the two of them, and we're going to look at a formula that can relate the two together as well. It's a formula that you'll use quite a lot throughout physics as well, so now is a really good time to learn it, I think. So let's start by looking at mass. What is mass? So you can think of mass as the amount of stuff there is, or the amount of stuff contained within that object, or the amount of matter contained within that object. Okay, so mass is a scalar quantity. You can't put a direction on the amount of matter there is, so it's a scalar quantity and it's measured in kilograms. Okay, now weight then. So you might have heard of the force of gravity. Yeah, so the force of gravity gives objects weight. It pulls it down towards the ground. It gives it weight. Weight, therefore, is a force measured in newtons. Yeah, and it's a vector quantity because it's a force. Yeah, it acts usually downwards or towards the center of whatever planet or whatever astronomical thing you're standing on. Okay, now let's think about what weight is then. So it's a force due to gravity on some mass or on an object. Yeah, so that's what our definition will be. It's the force on an object due to its position in a gravitational field. Okay, so the force on an object due to its position in a gravitational field. Now, let's look at the formula that we can relate the two together with. So weight then, if you take the mass of an object, the mass in kilograms, and you multiply it by the strength of the gravitational field that object is in, that's measured in newtons per kilogram, then you get weight, which is measured in newtons. Okay, so kilograms times by newtons per kilogram will give you newtons. Yeah. So mass times gravitational field strength is weight. Sometimes you'll see this written as W equals mg. Okay, you can put it into a formula triangle. We know that formula triangles always take the same structure with a multiplication there, divide. So it's m times g. Yeah, so just put W in the top. There's your formula triangle. Now, let's think about weight in more detail. So where does weight actually act on an object? Where is it pulling from? Well, we know weight is a non-contact force. Yeah, it doesn't. Things don't have to be touching the ground in order to experience weight. But you can think of it as acting from what's called the center of mass of the object. Okay, what is the center of mass of an object then? Well, the center of mass of an object is the point at which you can assume the entire mass of that object is concentrated. Yeah, and that's where it's pulling from. Usually, it's in the middle of the object. Yeah, if it's a constant density object, then usually it's in the middle of the object, and that's center of mass. Okay, right. Told you that will be a quick one. I'll see you in the next video.